In graph 8.5, we asked whether someone who saves will save more or less if the interest rate goes up. In graph 8.6, we asked whether someone who borrows will borrow more or less as the interest rate goes up. In both cases, we found that the answer was not unambiguous. It depended on which of the offsetting substitution and wealth effects was larger. The only thing we could say for sure was that a saver will consume more in the future, and a borrower will consume less now. We now turn to an in-between case, the case where, under the original interest rate, the person neither borrows nor saves. We then ask, if the interest rate goes up, will this consumer borrow or save, or can we tell for sure? We'll start with an intertemporal budget constraint that contains an endowment bundle E somewhere towards the middle. The endowment bundle is the bundle that the consumer can always consume regardless of what the interest rates are, because it requires no borrowing or saving. Thus, this consumer has income both this summer and next summer, and she could simply decide to consume that income in each of the summers when she earns it. We'll begin by assuming that she does just that. Her optimal bundle A is in fact her endowment bundle E. To be more precise, this consumer earns $5,000 this summer and $5,500 next summer, and her optimal consumption is to consume $5,000 worth of goods this summer and $5,500 worth of goods next summer. It's for this reason that she finds no need to borrow or save. As is always the case for an increase in the interest rate, an increase in that rate to 20% will cause the budget constraint to become steeper. It also causes the budget constraint to rotate through the endowment bundle, again as it always does. The only reason it looks different here is because the endowment bundle is now towards the center of the original budget rather than at one of the corners. You could in fact view this new magenta budget as being composed of two parts, the part that lies to the right of bundle E and the part that lies to the left of bundle E. To the right of bundle E, this consumer would become a borrower, and so the increase in the interest rate causes the choice set to shrink. To the left of bundle E, on the other hand, the consumer would become a saver, and an increase in the interest rate for a saver expands the choice set, as it in fact does to the left of bundle E. To see where this consumer might optimize on the magenta budget constraint, all we have to do is look at which portion of the magenta budget constraint lies above the original indifference curve. This portion is highlighted here. Notice that that portion lies entirely to the left of bundle E. Thus, we can conclude that this consumer will choose some bundle on this highlighted part of the magenta budget constraint and will therefore consume less now than she did originally. This implies that she will save now and therefore become a saver as a result of the increase in the interest rate. It turns out then that in this case we didn't have to decompose the behavioral response to an increase in the interest rate into substitution and wealth effects in order to answer the question of whether a person who neither borrowed nor saved originally will end up saving or borrowing when she experiences an increase in the interest rate. The reason for that is that what we're looking at in this problem is almost entirely a substitution effect, which we'll try to demonstrate in panel B. To find our usual substitution effect, we move the final magenta budget constraint inward until it is just tangent to the original indifference curve, and thus find our compensated budget. The point of tangency between the compensated budget and the original indifference curve is labeled, as always, bundle B. The movement from A to B is then our pure substitution effect. The wealth effect would start at bundle B and ask how will behavior change as we now increase income from the compensated green budget to the magenta final budget. But that wealth effect will necessarily be small because the difference between the green and the magenta budgets is small, and it can't possibly make the consumer worse off, and so it can't place the final bundle C to the right of bundle A. In this sense, the change in behavior is governed almost entirely by the substitution effect. There is, as we've mentioned briefly in Chapter 7 and explored in some of the Chapter 7 exercises, a different kind of substitution effect that is precisely at play here. Our usual substitution effect is arrived at by asking how much compensation is required in order to make the consumer just as well off as she was before the price change. Another way of arriving at a substitution effect is to ask the question slightly differently. How much money would we have to give this person in order for her to still be able to afford her original bundle? Those are two different questions, and they lead to two different definitions of substitution effect. The second question leads to a substitution effect known as the Slutsky substitution effect, and what we're observing in this example is in fact a Slutsky substitution effect, which is close to but not quite the same as our usual substitution effect.